Hello everyone, in this class we are going to continue with some more example and we will find the time complexity of all of those problems. So let's start. So let's say a problem is given as function for I equal to 1, I less than equal to n, I plus plus, and then for j equal to 1, j less than equal to n, j equal to 2 into j. Again we have one more loop for k equal to 1, k less than equal to n, k equal to 2 into k. Then we have this print statement. So how long it will take, that means what will be the time complexity of this particular problem. Now look at here. This print statement, again it will take only a constant time. Each time it will execute, it will take only a constant time to execute this particular print statement. That is sure. Now the problem is here we have three different loops. So we will see each of these loop, how many time means how many iteration each of this loop will take. That means how many times each of this loop will execute, we will see, and that is the number of iteration for each of this loop. So let's do it for the loop of I loop. Now how we can decide the number of iteration for a particular loop? By looking at the initial value, by looking on the initial value, the termination condition, and how it will increment. That means how we are going to change the value in each iteration. Based on these three things, we can decide how many times the loop will execute. That means the number of iteration we can find by using only these three elements, that is the initial value, that means from where the iteration will start, and the termination condition, that means where the loop will end, and the increment or decrement, that means how the iteration will increment or decrement. That means in each iteration how we will change the value of the counter variable. Based on these three things, we can check how long the loop will execute. So let's do it for each of these three loops. Now look at here for the I loop, that means our outermost loop. Here the initial value is 1. Clear? From here we get it. The termination condition is I less than equal to n. That means when it will stop, termination condition, when it will terminate, when the value of I less than equal to n. And next one is how we are going to change the value of I, that means increment. Here it is increment by 1 only. How we know this thing? Because the instruction given as I plus plus. So how many iteration will be there? Each time we increment the value of I by 1 only. So the value of I will be 1, then 2, then 3, then 4, like that. How long it will continue? Till n. That means total how many iterations are there? Total iteration is n. For the outermost loop, that means for I loop, we have total n iteration. Now come to the next loop, that is j loop. So j loop. Now look at here. Initial value is initialized with 1, that means the j loop start from 1, continue till or termination condition is what? J less than equal to n. Clear? That means termination condition given as j less than equal to 1. That means how long it will continue? It will start from 1 and continue till n. And how we are going to increment the value of j? That is, next instruction given as j equal to 2 into j. That means what? What does it mean? It means we are going to double the value of j after each iteration. We are going to double the value of j after each iteration. So let's check for which value the loop will execute. So first value that we have is 1. After that the value of j will incremented by 2. That means we will get 2. After that we will get the value that is double of 2, that means we will get 4, and then after that we will get 8, and after that we will get 16, like that. How long it will continue? It will continue till n. And we already saw one example in our previous examples where we increment the counter variable by using multiplying 2 as well as multiplying 3. In both cases, in such cases when we increment the counter by doubling the counter value in each iteration, in such case the total number of iterations that we will get is log n, and base will be that number. Which number? The multiplication number. So here how many iterations are there? Total iteration will be log n base 2. These many iterations we have for the loop, for the j loop, and these many iterations we have for each of iteration of I. That means what? What does it mean? That means for each iteration of I, the j loop will execute how many iteration? Log n base 2 iteration. Hope you understood the concept. Look, when the value of I equal to 1, at that time this condition becomes true and we come to this particular iteration, and it will execute for how many times? It will execute for log n base 2 times. After that the value of I incremented by 1 and it becomes 2. Again we come here, again it will execute for log n base 2 time. Like that the iteration continues. Clear? So this is for our j loop. Now we have k loop. Now we have this k loop. Now look at here, if you observe one thing, this k loop is exactly same as j loop. Exactly same as j loop. That means the k loop again start from 1, initialized with 1, the termination condition is k less than equal to n, k less than equal to n, the increment, the value of the k loop is again multiplied by 2, again multiplied by 2. That means this loop is also execute for how many time? Log n base 2 time. This loop again execute for how many time? Log n base 2 time. But when this loop will execute for each of the j loop, each value of j, we have this many iteration for k loop. That means for each iteration of j, the k loop will execute for how many iteration? Log n base 2 iteration. Clear? So that is the final conclusion. Now we can find the total number of iteration. That means total how many times this print instruction will execute. Total how many times this print instruction will execute, that thing we can find now. Now look at here, the I loop, how many iterations are there? N iteration. Then j loop, how many iterations is there? We have total log n base 2 iteration for each value, for each iteration of I. And total how many iterations are there for I? For I we have total n iterations. That means how many times this j loop will execute? Total execution of j loop, how many times? For each of these I iteration, the j loop will execute for log n base 2 time. That means we have total n iteration. That means total iteration in j loop will be n log n base 2 time. These many iterations are there for the j loop. Total execution of j loop will be this iteration. Now now we have one more loop, that is called k loop. Now again, for each iteration of j loop, we have the k loop will execute for log n iteration. That means k loop, each time how many iterations are there for k loop? We have log n base 2 iteration. Clear? For k loop we have log n base 2 iteration, and this thing happens for each iteration of j loop. Now how many j iteration is there? Total j iteration is n log n base 2, and in each of these iterations the k loop will execute for log n base 2. That means total execution for k loop will be how long? How many iterations will be there? That will be n log n base 2, and then this iteration that is log n base 2. These many iterations will be there. Now this is our total number of iteration for which this print instruction will execute. This is our total number of iteration for which this print instruction will execute. Clear? Now look at here. This thing means n log n base 2 whole square. So what will be the time complexity for this particular problem? The time, this is the total number of iterations, so therefore total time will be now look at here, this is the total number of execution and each execution will take only constant time, so total time will be n log n base 2 whole square multiplied by c. This is our total time required for this particular problem to execute. Now the time complexity. Therefore the time complexity of this particular problem will be order of n log n base 2 whole square. Clear? This is our time complexity for this particular problem. Now this is the whole approach how we can find the time complexity of any given problem. Now once you understood the whole concept, you don't need to go through all these approaches. You, by looking at the loop itself, you can find the time complexity of any particular problem. Now look at here. After you complete the whole approach, once you understood the concept, now look at the problem again. Now look at the problem again. Now we don't have all these things. I am assuming that you already understood all these concepts. Now by looking on the problem itself, I am going to find this particular time complexity. How we can find this thing from this particular given problem directly by looking at the problem itself. Now look at here. The value of I start from 1, continue till n and incremented by 1. That means how many iterations will be there? There are only n iterations. How we got it? Because each time the value of I incremented by only 1. That means the value of I will be 1, 2, 3, 4, 5, 6, 7, 8 like that till n. So we have here n iteration. Now come to the inner loop. In inner loop, the value of I start from 1, continue till n, and in each time we will double the value of j. That means what will be the scenario? That means for which value of j we have this iteration for j. That is, the value of j will be j equal to 1, then we double the value of j, that is 2, and then again double, that means we become 4, then 8, then 16, then 32, then 64, then next what? 128, then after 128, 512, and then 1024. That means each time we double the value of j. And in such case, whenever we double the value, at that time the complexity we will get is log n base 2. So for this particular problem, we have log n base 2 iteration. And again for this k loop also we have log n base 2 iteration. That means total how many iterations is there? The outermost loop will execute for n iteration, and each of these iteration the j loop will execute for n log base 2 iteration, and each of these iteration the k loop will execute for log n base 2 iteration. Hope you understood. Again, we have for I we have n iteration. Within this n iteration for each, the j loop will execute for log n base 2 iteration. That means again among this log n base 2 iteration, the k loop will execute for log n base 2 iteration. That means total how many iteration will be there? multiplication of all these elements, that means we will get n log n base 2 again log n base 2 iteration. This is how we can directly find the number of iteration. This is our number of iteration. Then how long it will take? That means what will be the total time? Total time will be, this is the iteration and each iteration will take only constant time. So total time will be this iteration multiplied by the time, constant time. So this is our time, and within this time this is our number of iteration, and this is in each iteration how long it will take to execute the problem. Next thing is, from this we can find out the time complexity. That means this total time we can convert it into approximate form of time, and that we call the time complexity. And what is that? That we get it here. Clear? Hope you understood the whole concept, how we are going to find out the time complexity from a given algorithm that used iterative approach. That means that has loop inside the algorithm. Clear? So that's it for this class. Thank you. See you soon in our next class.